You're standing on a rock. Not a metaphor. Not poetry. A rock. Spinning at 1,000 miles an hour, hurtling around a star at 67,000 miles per hour, tucked inside a galaxy that is itself moving through space at 1.3 million miles per hour. And you have absolutely no idea you're moving at all. That disconnect between the universe as it actually is and the universe as it feels is what this video is about. Because right now, at this very moment, Wu finally arrives. Nothing in the universe finally arrives. Nothing in the universe will look the same again. This is the story of the Andromeda Galaxy, our nearest large neighbor, our future, and the wall that will permanently define the limits of human exploration. Before we can talk about what's coming, we need to talk about where you are. The Earth has a diameter of about 8,000 miles. That sounds large. But if the Sun were the size of a basketball, the Earth would be a grain of sand 6 feet away. The Sun alone is so massive that 1.3 million copies of Earth could fit inside it, and you would still have room left over. But here's where it gets interesting. Our Sun, this incomprehensibly massive nuclear furnace, is completely, utterly average. Middle of the pack. One star among 400 billion in the Milky Way alone. And most of those stars have planets orbiting them. The Milky Way is not a star. It is a city of stars so dense that if you were to drive across it at the speed of light, it would take you 100,000 years to reach the other side. Now, hold that number in your mind. 100,000 years. At the speed of light. Because Andromeda is 25 times wider than that. On a clear night, away from city lights, if you know exactly where to look, you can see Andromeda with your naked eye. It looks like a tiny smear of light, a smudge on the sky. Easy to miss. Or what you're actually seeing is 1 trillion stars. 1 trillion stars. All compressed by distance into that faint blur. Andromeda is 2.5 million light-years away. That means the light reaching your eye right now left that galaxy 2.5 million years ago, before modern humans existed. You are not seeing Andromeda as it is. You're seeing Andromeda as it was when our ancestors were just learning to use stone tools. And yet, despite that distance, Andromeda is the closest large galaxy to the Milky Way, the nearest major island of stars in the ocean of space. It spans 220,000 light-years across, more than double the width of our own galaxy. And it contains approximately 1 trillion stars, roughly 2 to 3 times the stellar population of the Milky Way. It is, by every measure, bigger than home. And it is headed straight for us. Right now, as you watch this video, Andromeda is approaching the Milky Way at roughly 250,000 miles per hour. In approximately 4.5 billion years, these two galaxies will collide. Now, when you hear the word collide, the mind imagines a crash, an explosion, stars smashing into stars. The reality is far stranger. Galaxies are almost entirely empty space. The distance between individual stars is so vast that when two galaxies merge, almost no stars actually touch. The Milky Way and Andromeda will pass through each other, slowly, over hundreds of millions of years, like two clouds of smoke drifting through each other. What will happen instead is gravity. The gravitational forces of both galaxies will distort their shapes, flinging stars out into deep space, warping the spiral arms, and slowly, over billions of years, pulling the two systems into a single, merged galaxy that astronomers have already given a name: Milkomeda, a new galaxy born from the death of ours. So the Sun, if it still exists, will likely be flung into a completely different region of this merged structure. The night sky, if anything still lives to look up at it, will be unrecognizable, filled with the combined glow of 2 trillion stars. It will be, in purely visual terms, extraordinary. But here is where we need to zoom out even further, because the Milky Way and Andromeda are not alone. They are part of a gravitationally bound cluster of galaxies called the Local Group. Roughly 54 galaxies spread across 10 million light-years. Andromeda and the Milky Way are the 2 dominant members, like 2 massive planets in the same solar system. Beyond the Local Group is the Virgo supercluster, a region of space containing thousands of galaxies, stretching 110 million light-years across. And beyond that is the Laniakea supercluster, the structure the Milky Way calls home on the largest scale, spanning 520 million light-years and containing the mass of 100 million billion suns. These are not numbers anymore. They are a different language, a language the human brain was never built to speak fluently. And now I need to tell you something that most science videos skip past too quickly. Because somewhere in all of this scale and wonder is a fact so uncomfortable, so permanent, that once you understand it, you can't quite look at the stars the same way again. The universe is expanding. Not just expanding, accelerating. Every second, the galaxies beyond our local group are getting farther away, faster than before, driven by a force we call dark energy that we do not yet fully understand. And here is the implication that keeps physicists up at night. There's a distance threshold, a cosmic horizon, beyond which galaxies are receding from us faster than the speed of light. Not because they are traveling faster than light, but because the space between us and them is stretching faster than light can cross it. Those galaxies are, for all practical purposes, gone forever. Not destroyed, not dead, just permanently unreachable. No signal we send will ever get there. On no ship we build, even a hypothetical one traveling at the speed of light, could ever close the gap. The universe is pulling them away faster than physics allows us to follow. There are an estimated 2 trillion galaxies in the observable universe, but the accelerating expansion means that most of them are already beyond our reach, and that number, the number of galaxies we could ever physically visit, is shrinking. Right now, the Local Group, the Milky Way, Andromeda, and their companions, is the island we are confined to, the walls of our permanent neighborhood. Everything outside it is already leaving, has been leaving, will leave until it vanishes past the horizon. We are not at the center of the universe. We are not even near the center of the Milky Way. We are on a small rocky planet, orbiting an average star in the outer spiral arm of a galaxy that is itself just one of 2 dominant members of a cluster of 54 that is being carried further and further away from 99.99% of everything that exists. This is where you live. You might expect that information to feel crushing, and in a sense, it is. But here is what I keep coming back to. The fact that we can know this, that a species that appeared on this planet less than 300,000 years ago has managed, through curiosity and mathematics, and the patient accumulation of knowledge, to map the structure of the universe all the way to the edge of what's reachable. That is not a small thing. We looked up at that faint smudge of Andromeda, and we did not just name it. We measured its distance. We calculated its speed. We modeled the future collision down to the gravitational dance of individual star clusters. We have already named the galaxy that will replace ours before our great-great-grandchildren are born. That is a kind of defiance, not against the universe. So the universe is not threatening us. It is simply vast and old and indifferent to our timescales. but we chose to understand it anyway. To hold inside our minds something that no nervous system was ever designed to hold. To feel small and keep looking. The collision with Andromeda will happen with or without us. The cosmic horizon will keep retreating whether we watch it or not. The universe does not need our attention. We give it anyway, because that is what we do. So the Andromeda galaxy is 2.5 million light-years away. It contains 1 trillion stars. It is moving toward us at 250,000 miles per hour. In 4.5 billion years, it will arrive. And when it does, the 2 greatest structures in our local universe will spend hundreds of millions of years slowly becoming one. Stars will be flung across space. The sky will fill with light. And from somewhere in the merged chaos of 2 trillion suns, if anything is still there to look, the universe will appear even stranger and even more beautiful than it does tonight.